Embodied carbon versus carbon footprint in heating and hot water systems. There are two different terms when it comes to CO2 emissions: carbon footprint and embodied carbon. Carbon footprint refers to the total greenhouse gas emissions produced during its operation. This includes energy consumption, maintenance activities, and emissions from fuel combustion. On the other hand, embodied carbon refers to the carbon emissions associated with the production, transportation, installation, maintenance, and disposal of a product or system. This is a much more whole-life carbon approach and includes raw material extraction, manufacturing processes, and packaging and logistics. For building services, there are several instances of embodied carbon in heating and hot water products. The key contributors include the materials. Copper, aluminium, and plastics can have fairly high embodied carbon due to energy-intensive extraction and processing. Manufacturing is another contributor, as complex systems like heat pumps require precision engineering, often involving multiple global suppliers. Additionally, transport such as international shipping and road freight adds significant emissions. Also, installation involving on-site activities like welding and drilling consume energy and materials. Lastly, end of life with systems that are difficult to recycle or contain hazardous materials have higher embodied carbon. There are mitigation strategies we can use to reduce embodied carbon. The first is design for longevity. Longer-lasting systems reduce the frequency of replacement and associated embodied emissions. Another is modular components. Replacing parts instead of entire systems lowers embodied carbon. Also, local sourcing will reduce transport distances, cutting emissions. Recyclable materials is another strategy, as choosing materials with established recycling streams helps reduce end-of-life impact. There are also several key influences to carbon footprint in heating and hot water products. Firstly, fuel types such as natural gas, LPG, and oil have high carbon footprints, while electricity from renewables has a low footprint. Also, system efficiency in condensing boilers, modulating burners, and smart controls reduce energy use. Additionally, usage patterns such as oversizing systems or poor maintenance increases emissions. Grid carbon intensity is another factor, as how clean the grid is affects the carbon footprint of electric systems. System congruence and SPF is the last influencer. Embodied carbon assessments should be mindful of the complete operation of the system. There are reduction tactics to carbon footprint. The first is to switch to renewables, as they drastically cut operational emissions. Also, smart controls reduce unnecessary heating and optimize performance. Regular servicing also maintains efficiency and prevents energy waste. Lastly, user education can encourage responsible usage and have a big impact. To conclude, while carbon footprint is a vital metric, it is no longer enough. Embodied carbon is becoming more important, especially as systems become more complex. For professionals, understanding both metrics enables smart choices, balancing short-term gains with long-term sustainability. Whatever the task, the goal is to reduce total life cycle emissions and build a future with climate responsibility. To receive the latest information on renewable technologies, legislation, and best practice, sign up to our free newsletter today through our website or by simply scanning the QR code.